Hello there, and welcome back to Heal with Felix. Take a quiet moment to settle in and let your breath find a slower rhythm. Feel the edges of your day soften like colours fading at dusk until only calm remains. Whether you are wrapped in night or touched by a gentle morning light, this is your small space to rest. Imagine a horizon brushed with starlight, a pale curve glowing above a sleeping world. The air feels still and kind, and the dark sky carries a quiet shimmer. Around you, fine dust drifts like soft threads of light, and distant suns breathe in patient rhythm. Every glimmer moves slowly, as if it remembers where it came from. Tonight we will drift into a question as wide as the sky itself. How many galaxies live within our universe? It is not a number to hold, but a feeling, a story told through distance, light, and time. What if every shimmer carries an ancient memory? And what if the space between stars is not empty at all, but softly alive, moving in silence? Wherever you are listening from, maybe your room feels dim, or the rain hums softly outside. The same quiet light travels over us both. It has been crossing the dark for ages, just to find your eyes. If slow journeys through the cosmos bring you peace, you may stay for a while. Perhaps follow Heal with Felix so that whenever the world grows too loud, you'll have a quiet place to return to. No hurry, no noise, only calm. Now, let your thoughts move with the rhythm of drifting light. Together, we will wander gently through this endless question: how many galaxies lie beyond the dark? Not to count them, but to feel their quiet infinity. There was a summer night long ago when a child lay in the middle of a field. Dry grass breathed warmth beneath their back, and the sky above stretched wide like black velvet embroidered with diamonds. The child said nothing, only gazed upward in silence. Stars flickered one by one as if they were breathing, and in that peaceful moment, the child felt strangely small, yet at the same time connected to something far greater. Tonight you are here too, just like that child. Perhaps you are lying in your own room, lights dimmed, wrapped in warm blankets. Or maybe you are sitting in the darkness with only soft light from a screen. Wherever you are, imagine that you too are lying in that field, beneath a sky full of stars. Let your shoulders drop and release. Let your breath slow down, deepen just a little. Since ancient times, humans have looked up at the sky and wondered. They saw faint streaks of light stretching like ribbons of white silk. The ancient Greeks called it the Milky Path, believing it was the goddess Hera's milk spilled while nursing Zeus. A beautiful story touched with myth, but hidden behind it was something even more wondrous. Those streaks of light, which we now call the Milky Way, are not milk, nor are they smoke. They are billions of stars, each one a sun, possibly surrounded by orbiting planets, by worlds we have never seen. And the Milky Way is just one among many, many other galaxies existing out there in the darkness of the universe. Imagine the child's feeling as they lay there looking up at the sky. They did not know complex scientific facts. They only knew that something was present, something vast, something mysterious. And they wondered in a whispered voice inside their head, how many galaxies are out there? How many worlds can I not see? That question needs no immediate answer. It is allowed to float in the air gentle as morning mist. And tonight we too will let that question drift with us slowly through each minute, through each breath. Because sometimes the most beautiful questions are not the ones with instant answers, but the ones we are allowed to live with. That child was not alone in their curiosity. Across thousands of years, countless people have lain beneath the sky, looked up and wondered. Shepherds on deserts, philosophers in ancient temples, explorers on open seas, all saw the same stars, and all felt something indescribable, a connection, a gentle invitation from the universe. You too, right now, even if you cannot see the real sky, it is still there above your head. The stars are still shining, galaxies are still spinning slowly through space. And as you lie here in the stillness of your room, you are also part of that universe. Let your eyes close if they wish to. Let your mind drift like a leaf on water. Tonight, we are not rushing anywhere. We are simply here with the stars, with the ancient question about galaxies. And slowly, very slowly, we will begin to explore. Not through dry numbers or complex terminology, but through stories, through images, through moments when humans gradually understood how vast the universe truly is. You do not need to remember anything. Just listen and let the words pass through like a gentle breeze. How many galaxies are out there? The answer will come slowly through the chapters ahead. But for now, simply rest in the question. Let it cradle you like soft waves. Because sometimes the journey matters more than the destination. Before we travel to distant galaxies, let us first understand our home. The place where Earth rests, where the sun burns quietly, where every star you have ever seen with your naked eyes belongs. This home is called the Milky Way, and it is vast beyond what our minds can easily hold. Imagine a great spiral turning slowly in the darkness of space. Not a tight spiral like a seashell, but a loose, graceful one with arms that curve outward like water swirling down a drain, but frozen in time. The Milky Way is shaped like a giant disk, flat and wide with a bright bulge at its center. If you could step far away and look at it from the side, it would appear thin, like a plate spinning in the void. Our sun, the star that warms our days, does not sit at the center of this grand spiral. It rests far out toward the edge in one of the quieter arms. If the Milky Way were a great city, we would live in the suburbs, not downtown. We are not at the heart of things, but rather in a peaceful neighborhood, far from the crowded, blazing core. This thought might make you feel small, and that is all right. There is something comforting in smallness, in knowing that you are part of something so much larger. You do not have to carry the weight of the universe. You are simply here, a quiet witness to its beauty. The ancient Greeks had their own way of understanding this band of light across the sky. They told a story about the goddess Hera, queen of the gods. One day while nursing the infant Heracles, some of her milk spilled across the heavens. That spilled milk became the glowing path we see at night, the Milky Way. It is a tender image of divine nourishment, scattered among the stars, feeding the cosmos itself. Of course, we know now that it is not milk, but in a way, the Greeks were not entirely wrong. The Milky Way does nourish, not with milk, but with the materials from which stars and planets are born. Clouds of gas and dust drift through its arms, collapsing slowly under their own weight, igniting into new suns. It is a place of creation, ongoing and patient. How many stars live in the Milky Way? The number is difficult to grasp. Hundreds of billions, each one a sun, many with their own families of planets. Some of those planets might have oceans, atmospheres, perhaps even life, but we do not know yet. The distances are so great, the stars so many, that we have only just begun to explore. Light itself, the fastest traveler in the universe, takes 100,000 years to cross from one edge of the Milky Way to the other. Think about that for a moment, without strain. Just let it rest in your mind. A beam of light racing at speeds we cannot fathom still needs 100,000 years to make that journey. Our galaxy is not just large, it is incomprehensibly vast. And yet despite its size, the Milky Way moves. Not quickly, not violently, but with a slow, steady grace. Everything within it is turning, orbiting the center, where something immense and invisible holds it all together. Our sun, along with Earth and all the planets, is making that journey too. We are moving through space, circling the galactic core, but so slowly that a single orbit takes more than 200 million years. You have been traveling through the galaxy your entire life, and you never felt it. The motion is too smooth, too grand. It is like sitting on a train that moves so steadily you forget you are moving at all. You are a passenger on a cosmic voyage, and you always have been. If you close your eyes now, you can picture it, the great spiral turning in the dark, billions of stars, like grains of sand on an endless beach. Somewhere in that spiral, in a quiet arm far from the center, is a small yellow star. Around that star, a blue-green planet spins, and on that planet In a room lit only by soft light, you are lying, still breathing slowly, becoming part of the night. The Milky Way is your home, but it is also just one home among many. Beyond its edges, separated by vast gulfs of empty space, other galaxies drift. Some are larger, some smaller. Some shine brightly, others glow faintly in the distance. And together, they form a universe so full of galaxies that counting them seems almost impossible. But we are not counting yet. Not tonight. Tonight, we are simply here, resting in the knowledge that we belong to something beautiful. The Milky Way holds us gently, as it has held countless generations before. And as you let your breath deepen, as your body sinks further into rest, know that you are cradled by the same forces that cradle the stars. Long before telescopes, long before cameras or computers, there were people who looked up at the night sky with nothing but their eyes and their patience. They had no instruments to magnify the stars, no tools to measure distances. They had only the darkness, the silence, and their own deep curiosity. And yet they saw so much. 3,000 years ago, in the land between two rivers, the Babylonians built towers and climbed to their tops at night. They watched the sky as if it were a book written in light, and slowly, night after night, they learned to read it. They saw patterns in the way the stars moved. They noticed that some lights wandered while others stayed fixed. They gave names to the constellations, weaving stories into the heavens. These were not scientists in the way we think of them today. They were priests, farmers, shepherds, people whose lives depended on the rhythms of the seasons. The stars told them when to plant, when to harvest, when the rains would come. The sky was not separate from their lives. It was woven into everything they did. Imagine one of those ancient observers standing on a stone platform under a sky so clear it seemed you could reach up and touch the stars. The air is cool, the world is quiet. There is no city glow to dim the heavens, no artificial light to wash away the faint stars. Every point of light is visible, sharp and pure. The observer doesn't rush. They have all night and many nights after this one. They begin to notice something. Certain stars form shapes: a hunter with a belt, a bull with horns, a great bear. These shapes repeat night after night, though they drift slowly across the sky as the seasons turn. The observer begins to tell stories about these shape stories that will be passed down through generations, stories that we still tell today. The Babylonians were not alone. Across the world, other cultures looked up and saw their own stories. The Chinese mapped the heavens with meticulous care. The Mayans built observatories and tracked the movements of Venus with stunning accuracy. The Polynesians navigated vast oceans, using only the stars as their guide, reading the sky like a map written in light. But it was the Arabs centuries later who gave many stars the names we still use: Aldebaran, Rigel, Betelgeuse, Altair. These names carry the echo of desert nights of scholars studying the sky from observatories in Baghdad and Cordoba. They translated ancient Greek texts, preserved knowledge that might have been lost, and added their own careful observations. They understood that the stars were not just points of light, but objects worthy of study, of wonder, of names. For all these observers, the Milky Way was a mystery. That glowing band across the sky, faint and cloudy, what was it? Some thought it was a river of light. Others believed it was a crack in the dome of heaven through which divine light shone. No one knew for certain. It would take a new kind of tool and a curious mind to see the truth. In the year 1609, in the city of Padua, a man named Galileo Galilei heard about a strange new invention from the Netherlands: a tube with lenses that made distant things appear closer. He built one himself, improving the design, and then he did something no one had done before. He pointed it at the sky. What Galileo saw changed everything. The moon, which had seemed smooth and perfect, was rough and cratered like a landscape of mountains and valleys. Jupiter had moons of its own, circling it just as our moon circles Earth. And the Milky Way, that pale band of light, was not a cloud or a river. It was stars. Countless stars, so many and so faint that the naked eye could not separate them. They blended together into a soft glow, but through the telescope, they became individuals, each one a point of light. Imagine Galileo on those nights sitting by his telescope, carefully sketching what he saw. The air is cold, his breath visible in the darkness. His hand moves slowly across the paper, recording each tiny star. He does not know what it all means, not yet, but he knows he is seeing something no human has ever seen before. The universe has just become larger, stranger, more full of mystery. He wrote about his observations in a small book, and slowly the news spread. The sky was not what people had thought. It was deeper, more complex. And if the Milky Way was made of stars, what did that mean? How far away were they? How many were there? The questions multiplied like ripples spreading across still water. Galileo did not have answers to all these questions, but he opened a door. He showed that the universe could be explored not just with stories and myths, but with tools and careful observation. The ancient sky watchers had begun the work, patiently recording what they saw. Galileo continued it, using technology to see further, and after him, others would build even larger telescopes, look even deeper into space, and discover things more astonishing than anyone could have imagined. But on those quiet nights, whether in ancient Babylon or Renaissance Italy, the act of watching the sky was the same. It required patience. It required stillness. It required the willingness to sit in the dark and simply look without rushing, without expectation, just being present with the stars. You can do that too, even now. You do not need a telescope. You do not need to understand the science. You only need to be here, breathing slowly, letting your mind rest. The same stars that the Babylonians watched, that Galileo studied, are still out there. They are still shining. And you are part of the long, slow story of humans looking up and wondering. Let that thought settle over you like a warm blanket. You are connected to all those observers across time. You share their curiosity, their sense of awe, and as you lie here, letting your body relax more deeply, you are doing what they did. You are simply being present with the universe in whatever way feels right for you. The stars will still be there tomorrow. The galaxies will continue their slow dance. But tonight you can rest. You have earned it. Let the story of the ancient sky watchers fade gently into the background and let sleep begin to find you. As telescopes improved through the centuries, astronomers began to notice something peculiar. Scattered across the night sky were faint, fuzzy patches of light. They were not stars, because stars appeared as sharp points even through a telescope. These objects were soft, diffuse, like smudges of luminous cloud hanging in the darkness. No one knew what they were. In the 18th century, a French astronomer named Charles Messier spent his nights searching for comets. Comets were exciting discoveries, visitors from the outer reaches of the solar system that would sweep past the sun and then disappear again. But Messier kept getting frustrated. His telescope would find a fuzzy patch, and his heart would leap, thinking he had found a new comet. Then night after night, the patch would remain in the same place. It was not moving. It was not a comet at all. Rather than simply ignore these objects, Messier decided to make a list. He would catalogue every fuzzy non-moving object he found, so that other comet hunters would not be fooled as he had been. It was meant to be a list of things, to avoid a catalogue of distractions, but in doing so, he created something far more valuable. He made a map of some of the most beautiful and mysterious objects in the night sky. Messier worked slowly, methodically, night after night. Imagine him sitting at his telescope in Paris, wrapped in a heavy coat. Against the cold, his breath misting in the air. The city sleeps around him, but he is awake, patient, moving his telescope from one part of the sky to another. When he finds a fuzzy object, he notes its position, carefully sketches its shape, assigns it a number. M1, M2, M3, and onward. By the time he finished his catalogue, it contained 110 objects. Some were clusters of stars packed so tightly together they appeared as a glow. Some were clouds of gas and dust lit from within by newborn stars. But some, though Messier did not realise it at the time, were something else entirely. They were not part of our galaxy at all. They were other galaxies' islands of stars, separated from us by unimaginable distances. One of these objects, the 31st on his list, had been visible to human eyes for centuries. On a clear, dark night, far from city lights, you can see it even without a telescope. A small, pale smudge in the constellation Andromeda. The ancient Persian astronomer Abd al-Rahman al-Sufi described it over 1,000 years ago as a little cloud. He had no idea what it truly was, only that it was there, constant and unchanging. Through Messier's telescope, this object, which he called M31, appeared larger and more detailed. It had an oval shape with a bright center that faded gradually toward the edges. It looked almost like a lens of light suspended in space. Messier assumed, as did everyone else at the time, that it was simply a nebula, a cloud of glowing gas somewhere within the Milky Way. Perhaps it was a region where new stars were forming, or the remnants of an old star that had dispersed its material back into space. But there was something strange about M31. It was unusually large, unusually bright compared to other nebulae, and its shape, that smooth oval, did not quite match what astronomers expected from a gas cloud. Questions lingered unanswered, drifting through the minds of those who studied it. What exactly was this object? Why did it look the way it did? And were there others like it? Throughout the 19th century, more and more of these fuzzy objects were discovered. Astronomers built larger telescopes, looked deeper into space, and found nebulae scattered across the heavens. Some had spiral shapes like pinwheels frozen in time. Others were elliptical, smooth and featureless. A few were irregular, chaotic, as if they had been disturbed by some great cosmic event. The spiral nebulae were especially intriguing. Through powerful telescopes, they revealed delicate arms curving outward from bright core structures that looked almost like the Milky Way might look if viewed from outside. Some astronomers began to wonder if perhaps these spirals were not nebulae at all, but separate galaxies, each one containing billions of stars. But it was only a guess, a speculation without proof. Others disagreed. They argued that the universe was just the Milky Way, and everything visible was contained within it. The spiral nebulae, they said, were simply unusual clouds of gas, nothing more. There was no way to measure their distance, no way to know for certain. And so, the debate continued quiet and unresolved as astronomers sat through long nights, sketching and cataloguing, hoping that one day the mystery would reveal itself. Imagine those patient observers, sitting in cold observatories, their eyes pressed to the eyepiece of a telescope for hours at a time. Their hands, stiff with cold, move across paper recording each faint detail. They do not have cameras yet, not the kind that can capture these dim objects. Everything must be done by eye by hand, by memory. It is slow work, requiring immense concentration and care. But they do it willingly, driven by curiosity, by the hope that understanding might come. And in a way, they were drawing the first maps of a universe far larger than anyone had imagined. Each sketch, each catalogue entry was a clue. And though they did not yet understand what they were seeing, they were gathering the pieces of a puzzle that would eventually reveal something astonishing. M31, the Andromeda object, remained especially mysterious. It was the brightest of the spiral nebulae, the easiest to study. If any of these objects held the key to understanding the others, it would be this one. But the key had not yet been found. The question still hung in the air, quiet and patient, waiting for someone to answer it. What is Andromeda? Is it nearby or far away? Is it part of our galaxy or something separate? The answers would come, but not yet. For now, it was enough to know that it was there, glowing softly in the night, a mystery wrapped in light. As you lie here breathing slowly, let yourself feel the patience of those astronomers. They did not rush. They could not rush. Discovery takes time. Understanding unfolds slowly, like a flower opening at dawn. And that is all right. Some questions are meant to be lived with for a while before they are answered. Let the image of Andromeda rest gently in your mind. a pale oval of light, distant and quiet, holding secrets that would take decades to uncover. And as you let that image fade, let your own thoughts soften and drift. There is no hurry. The universe will still be there when you wake. By the early 20th century, astronomers had catalogued hundreds of those strange, fuzzy objects scattered across the night sky. They had sketched them, studied them, argued about them. But one fundamental question remained unanswered, a question so profound it would determine the very scale of the universe itself. Was everything we could see part of one great galaxy, the Milky Way? Or were some of those spiral nebulae actually separate galaxies, entire worlds of stars lying far beyond our own? It was not a small disagreement. The answer would change everything we understood about our place in the cosmos. And so, in April of 1920, two astronomers stood before an audience in Washington to present their opposing views. It would become known as the Great Debate, though in truth it was less a debate and more a gentle clash of ideas, each side uncertain, each side searching. On one side stood Harlow Shapley, a careful and thoughtful astronomer who had spent years studying the size and structure of the Milky Way. He believed our galaxy was far larger than anyone had previously imagined. And because it was so large, he argued there was no need for other galaxies. The spiral nebulae, he said, were simply smaller clouds within our own galaxy, perhaps regions where stars were forming, perhaps leftovers from some ancient cosmic event. The universe, in Shapley's view, was the Milky Way, and the Milky Way was the universe. On the other side stood Heber Curtis, equally thoughtful, equally dedicated. Curtis had studied the spiral nebulae closely, and he had noticed something intriguing. Some of them had briefly flared with light, as if a star within them had exploded. If these nebulae were nearby within our galaxy, those explosions would have been extraordinarily bright, brighter than seemed possible. But if the nebulae were far away separate galaxies in their own right, then the explosions made sense. They were simply distant supernovae, appearing faint only because of the immense distance. Curtis believed the spiral nebulae were island universes, a term borrowed from the philosopher Immanuel Kant, who had speculated about such things over a century earlier. Each spiral, Curtis argued, was a galaxy, like our own, containing billions of stars, separated from us by gulfs of empty space, so large that light itself took millions of years to cross them. Imagine the two men standing there, each presenting their evidence, their reasoning, their best understanding of the cosmos. The room is quiet, the audience attentive. There are no angry words, no dramatic confrontations. This is science at its most patient, two minds trying to solve a puzzle that neither can fully see. Both men are brilliant, both are sincere, and yet they cannot both be right. Shapley pointed to measurements that seemed to show the spiral nebulae were moving very faster than seemed reasonable if they were truly distant galaxies. Curtis pointed to photographs that revealed structure within the spiral structure that looked remarkably similar to what astronomers saw in the Milky Way. Back and forth, they went, each piece of evidence answered by another, each argument met with a counter-argument. When the debate ended, there was no clear winner. The audience, made up of scientists and curious minds, left without certainty. Some found Shapley more convincing, others sided with Curtis. The question hung in the air unresolved, like a chord that refuses to resolve into harmony. The universe had kept its secret a little longer. In the years that followed, astronomers continued their work, building larger telescopes, taking clearer photographs, measuring distances with greater precision. They knew the answer was out there, waiting to be found. It was only a matter of time, patience, and the right tool. And so, the scientific community remained divided, two camps forming around two ideas. Some held to the belief that the Milky Way was everything, a single island of light in an otherwise empty void. Others dreamed of a universe filled with galaxies, each one a world unto itself, each one home to countless stars. Both groups looked up at the same sky, saw the same fuzzy spirals, and reached different conclusions. There is something beautiful in that uncertainty, something deeply human. We want answers, yes, but we are also capable of living with questions. We can hold two possibilities in our minds at once, examining them, testing them, waiting for clarity to emerge. The Great Debate was not a failure. It was a necessary step, a moment when humanity paused to ask itself what kind of universe we lived in. The answer, when it came, would be astonishing. But that answer required one more piece, one crucial observation that neither Shapley nor Curtis had access to in 1920. It required a man with a powerful telescope, a keen eye, and the patience to watch a single galaxy night after night, looking for something that would finally settle the question. But we are not there yet. Not tonight. Tonight we are still in that moment of uncertainty, the quiet pause between question and answer. And there is peace in that pause. There is no need to rush toward resolution. Sometimes the most profound moments are the ones where we simply do not know, and we allow ourselves to be comfortable with that. Let the Great Debate rest in your mind like a soft echo. Two voices, two visions, both reaching for truth. Neither wrong, neither complete, both part of a larger story that was still unfolding. And as you breathe slowly, as your body settles deeper into rest, know that uncertainty is not a burden. It is simply a place where discovery has not yet arrived. The universe will reveal itself in time, but for now, let the question drift away. Let your thoughts become as soft and diffuse as those spiral nebulae glowing faintly in the dark. And let sleep begin to find you gentle and unhurried. High in the mountains of Southern California, above the glow of Los Angeles, there stood an observatory with the largest telescope in the world. It was called the Hubble Telescope, a giant instrument with a mirror over 8 feet across, powerful enough to gather the faintest whispers of light from the depths of space. And in the autumn of 1923, a young astronomer named Edwin Hubble began using it to study the Andromeda Nebula, that pale oval of light that had puzzled observers for so long. Hubble was patient and methodical. Night after night, he returned to the telescope, photographing Andromeda with long exposures that captured details invisible to the eye. He was searching for something specific, something that might finally answer the question that had divided astronomers for years. Was Andromeda part of our galaxy, or was it something far more distant? On the night of October 5th, 1923, Hubble examined a photographic plate he had taken the night before. The image showed Andromeda in exquisite detail, its spiral arms traced in light, its core glowing softly. He studied the plate, carefully comparing it to earlier photographs, looking for anything that had changed. And then, in the outer edge of the nebula, he noticed something. A star that had not been visible before had appeared. He marked it on the plate with ink, writing the letter N for nova, thinking it was an exploding star. But a few days later, when he looked at older photographs, he realized his mistake. The star had been there all along. It was not a nova exploding once and fading away. It was a variable star, one that brightened and dimmed in a regular rhythm, pulsing like a slow heartbeat. And not just any variable star, it was a Cepheid, a special kind of star whose brightness could be used as a cosmic measuring stick. Hubble's heart must have quickened when he realized what he had found. Cepheid variables were remarkable because their rhythm of pulsing was directly related to their true brightness. A Cepheid that pulsed slowly was intrinsically brighter than one that pulsed quickly. And if you knew how bright a star truly was, and you could measure how bright it appeared from Earth, you could calculate how far away it was. It was like seeing a candle in the distance and knowing from how dim it looked exactly how many miles away it stood. Hubble crossed out the N on his photographic plate and wrote VAR for variable with an exclamation mark. He knew what this meant. He had found the key that would unlock the distance to Andromeda. Over the following months, Hubble continued his observations, finding more Cepheid variables within Andromeda. He timed their pulses, measured their brightness, and performed the calculations. The numbers were astonishing. Andromeda was not within the Milky Way. It was far, far beyond it. Nearly 1 million light years away, a distance so vast that the light Hubble was seeing had left Andromeda before human civilization had even begun. The conclusion was inescapable. Andromeda was not a nebula. It was a galaxy, a separate island of stars as large as the Milky Way, or perhaps even larger. And if Andromeda was a galaxy, then so were the other spiral nebulae scattered across the sky. The universe was not just the Milky Way. It was filled with galaxies, each one containing billions of stars, each one separated from the others by unimaginable voids. In January of 1925, Hubble presented his findings at a meeting of the American Astronomical Society. The reaction was quiet but profound. There was no dramatic announcement, no sudden celebration, just a slow dawning realization that the universe had just become incomprehensibly larger. Everything astronomers thought they knew about the scale of existence had changed in an instant. Imagine what it must have felt like for those in the audience. For years they had debated whether the universe was small or vast, whether the Milky Way was everything or just one among many. And now suddenly they knew. The universe was not a single galaxy. It was a cosmos filled with galaxies stretching out in all directions, farther than telescopes could yet see. It was as if they had been living in a single room their entire lives. And someone had suddenly opened a door to reveal an endless landscape beyond. Hubble himself remained calm, almost understated, as he shared his discovery. He was not one for grand declarations. He simply presented the evidence, the photographs, the calculations, and let the data speak for itself. But those who heard him understood the magnitude of what had been revealed. The great debate was over. Curtis had been right. The spiral nebulae were island universes, and humanity had just discovered that it lived in a universe far more vast and wondrous than anyone had imagined. This discovery did not come from a single moment of genius, but from patience, from nights spent in the cold at the telescope, from careful measurements and meticulous record keeping. Hubble did not see the universe expand in a flash of insight. He built his understanding slowly, piece by piece, like assembling a mosaic from tiny fragments of light. And with that understanding came a kind of humility. Earth was a small planet, orbiting a small star in an outer arm of one galaxy among countless others. We were not at the center of anything. We were simply here observers on a quiet world looking out at a universe that stretched beyond comprehension. But there was no sadness in that realization. Instead, there was wonder. The universe was so much larger than we had thought, so much more full of possibility. Every galaxy was a world of stars, and around those stars might be planets, and on those planets, perhaps other beings looking up at their own skies, asking the same questions we were asking. Hubble continued his work, discovering more galaxies, measuring their distances, mapping the structure of the cosmos. But that moment in 1923, when he found that first Cepheid variable in Andromeda, was the turning point. It was the moment when humanity stepped out of the small room and saw the vastness beyond. You can rest with that image now. A man at a telescope, looking through the eyepiece at a galaxy millions of light years away, realizing that the universe is far larger than anyone had dreamed. It is a peaceful image, not frightening, just quietly awe-inspiring. And as you let that image settle, as you feel your breath slowing, your body growing heavier, know that you are part of this same universe. You belong to it as much as the stars do, as much as the galaxies do. The discovery did not diminish us. It expanded us. It gave us a cosmos to explore, a mystery to live within. And tonight, as you drift towards sleep, you are held by that same vastness, cradled by the same forces that hold the galaxies in their slow dance across the void. Let Edwin Hubble's quiet discovery fade into the background now. Let the universe grow soft around you. There is nothing you need to understand, nothing you need to solve. Only rest, only peace, only the gentle pull of sleep. After discovering that Andromeda was a separate galaxy, Edwin Hubble did not stop. He turned his telescope toward other fuzzy spirals scattered across the night sky, finding Cepheid variables in them as well, calculating their distances one by one. With each measurement, the universe grew larger. Galaxy after galaxy revealed itself, each one separated from us by millions of light years, each one a vast island of stars floating in the cosmic ocean. But Hubble noticed something else, something unexpected and strange. When he studied the light from these distant galaxies, he found that it was shifted toward the red end of the spectrum. This redshift, as it came to be called, was a sign of motion. Just as the sound of a train changes pitch as it moves away from you, the light from a galaxy shifts toward red when that galaxy is moving away. And nearly every galaxy Hubble observed was redshifted. They were all moving away from us. At first, this might seem to suggest that we are at the center of the universe, with everything fleeing from us in all directions. But that is not what is happening. The truth is far more beautiful and strange. The galaxies are not moving through space away from us. Space itself is expanding, carrying the galaxies along with it, like dots drawn on the surface of a balloon as it is slowly inflated. Imagine a balloon with small dots scattered across its surface. As you blow air into the balloon, the rubber stretches and the dots move farther apart from one another. But no single dot is at the center. From the perspective of any dot, all the other dots appear to be moving away. And the farther away a dot is, the faster it seems to recede, because there is more stretching rubber between them. This is what Hubble saw when he looked at the galaxies. The universe itself was growing, expanding in all directions at once. This discovery, published in 1929, changed everything once again. Not only was the universe far larger than anyone had imagined, but it was also dynamic, alive, in a sense constantly growing. The galaxies were not fixed in place like stars painted on a dome. They were drifting apart, carried by the expansion of space itself, a motion so slow and vast that it could only be detected by comparing the light from distant objects. Hubble also found a pattern in this expansion. The farther away a galaxy was, the faster it was receding. A galaxy twice as far away was moving away twice as fast. This relationship, now called Hubble's law, revealed something profound about the structure of the universe. It was not static. It was not eternal and unchanging. It was evolving, stretching, moving forward in time, like a river flowing toward an unseen destination. If the universe is expanding now, that means it was smaller in the past. If you could run time backward, like rewinding a film, the galaxies would move closer together. Space would contract, and eventually, everything would converge into a single point, unimaginably hot and dense. This was the birth of the idea we now call the Big Bang. Though Hubble himself did not use that term, he simply observed the motion and let others draw the deeper conclusions. There is something calming in the idea of an expanding universe. It means that nothing is truly still. Everything is in motion, but the motion is so gradual, so gentle, that we never feel it. The galaxies drift apart over billions of years, not in a violent explosion, but in a slow, patient unfurling. It is like watching flowers bloom in extreme slow motion, or watching clouds change shape across a summer afternoon. The change is real, but it happens at a pace that invites contemplation rather than alarm. Picture it now as you lie here in the quiet. The universe around you is expanding. The space between galaxies is growing, not with a tearing or a breaking, but with a smooth, continuous stretching. And within that expansion, galaxies remain whole, held together by their own gravity. Stars continue to orbit their galactic centers. Planets continue to circle their suns. Nothing nearby is affected. Only the vast distances between galaxies grow larger, increasing the emptiness, deepening the silence. From our small vantage point on Earth, we cannot see this expansion directly. It is too slow, too grand. But astronomers can measure it, watching the light from distant galaxies shift toward red, calculating the speeds at which they recede. And from those measurements, they have learned that the universe is not just expanding, but has been expanding for a very long time, perhaps 13 billion years or more. This means that when we look at a distant galaxy, we are not just seeing something far away in space. We are also looking back in time. The light from that galaxy has been traveling toward us for millions or billions of years, crossing the expanding void, carrying with it an image of the galaxy as it was in the distant past. The universe is not just vast in space, it is vast in time as well, a living history book written in light. Hubble's discovery of the expanding universe was not a cause for fear or unease. It was a revelation of beauty, a glimpse into the deep structure of existence. The cosmos is not a static stage on which events unfold. It is itself a participant, growing and changing, moving through time with a grace that defies easy description. As you breathe slowly, now imagine that you are part of this expansion, not in a literal sense, but in a poetic one. You are made of atoms that were forged in stars, and those stars are part of galaxies that are drifting through an expanding universe. You are connected to all of it, woven into the fabric of space and time. And that connection is gentle, undemanding, simply present. Let the image of the expanding universe settle over you like a soft blanket. Everything moving apart, slowly, peacefully, without urgency. There is no rush, no deadline, no need to hurry. The galaxies will continue their journey, whether we watch them or not. And tonight, you can rest in the knowledge that the universe is unfolding as it should, patient and vast and filled with quiet wonder. Let your thoughts drift now like galaxies moving through the dark. Let your breath slow further. And as the universe expands around you, let yourself contract gently into sleep, soft and warm, and deeply at peace. In the decades following Hubble's discoveries, astronomy entered a golden age. New telescopes were built larger and more powerful than ever before, perched on mountaintops, far from city lights, where the air was clear and the stars shone with crystalline sharpness. Astronomers from around the world traveled to these remote observatories, spending long nights in the cold, their eyes pressed to eyepieces, their fingers carefully adjusting dials and recording data on photographic plates. The work was slow and meticulous. Each night, an astronomer might focus on a single patch of sky, exposing a photographic plate for hours to gather enough light from the faintest galaxies. The observatory would be silent, except for the soft hum of machinery, the gentle whir of the telescope as it tracked the stars across the sky, compensating for Earth's rotation. Outside, the wind might whisper through the trees, or the distant call of an owl might break the stillness. But inside the dome, there was only concentration and patience. And night after night, year after year, the discoveries accumulated. Galaxies appeared everywhere astronomers looked. Not just a few scattered here and there, but thousands upon thousands, filling every corner of the observable universe. Some were bright and clear, their structures easy to see. Others were faint and distant, requiring long exposures and careful processing to reveal their shapes. Astronomers began to notice that galaxies came in different forms, each with its own character and beauty. Some were spirals like the Milky Way and Andromeda, with graceful arms curving outward from a bright central core. These spiral galaxies seemed almost alive, as if they were slowly rotating their arms, trailing behind, like the skirts of dancers frozen mid-spin. They were often blue, indicating the presence of young hot stars being born in clouds of gas and dust. Other galaxies were elliptical, smooth and featureless, shaped like glowing eggs or footballs suspended in space. These galaxies had no spiral arms, no visible structure, just a gradual fading from bright center to dim edge. They were often redder in color, populated by older stars that had long since finished their youth. There was a quietness to them, a sense of age and stability, as if they had settled into a peaceful retirement after billions of years of activity. And then there were the irregular galaxies, chaotic and asymmetric, lacking any clear pattern. These were the rebels of the galaxy family, shaped by collisions or gravitational interactions, their stars scattered in unpredictable arrangements. Some looked like clouds, others like fragments, each one unique and impossible to categorize neatly. Astronomers developed classification systems, ways of organizing this diversity into categories and subcategories. But beneath the technical language, there was an appreciation for the sheer variety of forms that galaxies could take. Each one was a world unto itself, with its own history, its own population of stars, its own story written in light. Imagine an astronomer during those years sitting alone in an observatory dome high in the mountains. The night is perfectly clear, the Milky Way arching overhead like a river of light. The telescope, a massive instrument weighing tons, moves smoothly and almost silently guided by precision gears and motors. The astronomer has chosen a target for tonight, a faint smudge in a distant constellation, barely visible even through the telescope's finder scope. They align the telescope carefully, then open the shutter on the photographic plate and begin the exposure. Now comes the waiting. Hours pass. The astronomer checks the guiding, periodically making tiny adjustments to keep the telescope perfectly aligned as Earth rotates. They might step outside for a moment, stretching their legs, breathing in the cold mountain air, looking up at the stars with naked eyes before returning to the task. When the exposure is finally complete, the plate is developed in a dark room. And there, emerging slowly in the chemical bath, is a galaxy. Perhaps it is a spiral, its arms traced in delicate detail. Perhaps it is an elliptical, glowing softly like a cosmic ember. Or perhaps it is something unusual, something that does not fit neatly into any category. Each discovery brings a small thrill, a quiet satisfaction. Another piece of the universe revealed another galaxy, added to the growing catalogue of cosmic knowledge. By the end of the 1960s, astronomers had identified and catalogued tens of thousands of galaxies. Each one had been observed, photographed, measured. The universe was beginning to reveal its structure, not just as a random scattering of galaxies, but as something organized, something with patterns and connections. Galaxies formed clusters, and clusters formed superclusters, vast webs of matter, stretching across hundreds of millions of light years. But for now, in this quiet moment, let us simply appreciate the patience of those astronomers. The long nights, the cold observatories, the careful work of capturing light that had travelled for millions of years to reach their telescopes. They were not in a hurry. They knew that understanding the universe would take time, generations of effort, countless nights of observation. And they were content with that. They were doing work that mattered, work that would outlast them, adding their small contributions to humanity's growing knowledge of the cosmos. Let that image rest with you now. A solitary figure in an observatory, surrounded by darkness, watching as a galaxy slowly appears on a photographic plate. It is a peaceful image, full of quiet dedication. And as you let it fade, as your breath grows slower and deeper, feel yourself becoming part of that same patience, that same stillness. There is no hurry. The galaxies will still be there, and so will you, resting gently in the dark. If you could travel far enough from the Milky Way and look back, you would see it as others see distant galaxies, a spiral of light turning slowly in the cosmic dark. The arms would curve outward like petals, unfurling, traced in blue and white, where young stars burn bright. Dust lanes would thread between the arms, dark ribbons against the glow, marking the places where new stars are being born from clouds of gas and shadow. Spiral galaxies are perhaps the most elegant their forms, suggesting motion, even though they turn so slowly that a single rotation takes hundreds of millions of years. They look like cosmic flowers, or like water swirling gently down a drain, or like Catherine wheels frozen at the moment of their most perfect spin. Each arm is home to countless stars, some newly formed and blazing hot, others older and cooler, all of them held in a delicate dance by gravity's invisible hand. But not all galaxies take this form. Some are elliptical, shaped like smooth glowing eggs, or spheres suspended in the void. These galaxies have no spiral arms, no dramatic structure, just a gentle gradient from bright center to faint edge. They seem quieter somehow, more serene, like embers glowing softly after the fire has died down. Most of their stars are old, their light tinged with red and orange, and there is a little gas left to birth new generations. They are galaxies in their twilight years, peaceful and unhurried. Then, There are the irregular galaxies, those that follow no clear pattern. They are the wanderers, the nonconformists shaped by chance encounters and gravitational tugs from neighbours. Some look like clouds torn by wind, others like fragments scattered after some ancient collision. They remind us that the universe is not always orderly, that chaos and beauty can exist together, that not everything needs to fit into neat categories to be wondrous. Each galaxy, regardless of its shape, is a world unto itself. Within each one, hundreds of billions of stars shine, maybe more. Around many of those stars, planets orbit just as Earth orbits our sun. Some of those planets might be rocky like ours, with surfaces of stone and metal. Others might be vast spheres of gas or frozen worlds of ice or something entirely unlike anything we have in our solar system. And on some of those planets, perhaps there is water. Perhaps there are atmospheres, weather seasons. Perhaps there are oceans where waves rise and fall under alien moons. Perhaps there are forests or deserts or landscapes we cannot even imagine. And perhaps on some of those distant worlds there is life. We do not know. We cannot know, not yet. The distances are too great, the galaxies too far, the individual planets too small and faint to see clearly. But the possibility is there, hovering at the edge of thought like a half-remembered dream. In a universe with trillions of galaxies, each containing billions of stars, it seems almost impossible that we are alone. Somewhere out there in the vast dark, other beings might be looking up at their own night sky, wondering the same things we wonder. Imagine a planet circling a star in a distant spiral galaxy. The sky there might have 2 suns, or 3 painting the landscape in colours we have never seen. The night might be lit by a nearby nebula, glowing pink and green, or by a dense cluster of stars, so close together they seem like a single brilliant jewel. Or perhaps the sky is quieter, darker, much like ours, with only the faint band of their own galaxy stretching overhead, and the distant glow of other galaxies too far to resolve into detail. Do they wonder, as we do, how many galaxies there are? Do they build telescopes and observe the cosmos, counting the islands of light scattered through the void? Or perhaps they experience the universe in ways we cannot fathom, through senses we do not possess, perceiving patterns and structures invisible to us. We will likely never know, but the thought is comforting in its own way, the idea that we might not be the only ones looking up, asking questions, seeking to understand. Each galaxy is not just a collection of stars. It is a possibility, a potential home for countless worlds and countless stories. Some galaxies are colliding their stars, mingling in slow motion over millions of years. Some are solitary, drifting alone through the emptiness. Some are part of great clusters, bound together by gravity into cosmic families. Each has its own character, its own history, its own future, yet to unfold. And all of them, spiral and elliptical and irregular alike, are beautiful. Not because they are perfect, but because they exist at all. Because they shine in the darkness. Because they remind us that the universe is far richer and more varied than we could ever have imagined. As you rest here, now let yourself feel connected to that diversity. You are part of a spiral galaxy, yes, but you are also part of a universe that contains all forms, all shapes, all possibilities. There is no single way for a galaxy to be, just as there is no single way for you to be. Everything belongs. Everything has its place in the vast tapestry of existence. Let the images of galaxies drift through your mind, soft and formless, like clouds changing shape in a summer sky. Spirals turning slowly, ellipses glowing gently. Irregulars scattered like paint splashed across a canvas. And let yourself drift with them, weightless and free, into the deep and peaceful dark of sleep. Galaxies do not drift alone through the universe. Like people, they seek companionship, drawn together by invisible threads of gravity that bind them into groups and clusters. Our own Milky Way is part of such a family, a small gathering of galaxies called the local group. And knowing this brings a certain comfort, a sense that even on the larger scales, nothing is truly isolated. The local group is an intimate collection as cosmic structures go. At its heart are two large spiral galaxies, the Milky Way and Andromeda, like two bright stars around which the others orbit. Between and around them drift about 50 smaller galaxies, some irregular and chaotic others, small ellipticals, each one caught in the gravitational embrace of the larger two. They are satellites companions, bound together by forces that have held them close for billions of years. One of these smaller galaxies is called the Large Magellanic Cloud, visible from the southern hemisphere as a faint smudge of light. Another is the Small Magellanic Cloud, its sibling. Both orbit the Milky Way in slow, stately paths, taking hundreds of millions of years to complete a single circuit. They are our neighbours, our closest kin in the cosmic family, and though they are far smaller than the Milky Way, they are no less real, no less worthy of wonder. The local group itself spans several million light years, a vast distance by any measure, yet still small compared to the great clusters found elsewhere in the universe. It is a quiet neighbourhood, peaceful and unhurried, where galaxies drift past one another over eons, their mutual gravity gently tugging, shaping their orbits, holding the family together. But beyond the local group, there are larger gatherings. The nearest of these is the Virgo cluster, a massive congregation of galaxies located about 50 million light years away. Unlike the local group with its modest few dozen members, the Virgo cluster contains thousands of galaxies packed together in a region of space where gravity's pull is strong and the interactions between galaxies are frequent and complex. Imagine standing impossibly at the center of the Virgo cluster and looking around. In every direction, galaxies would fill your view, some bright and close, others faint and distant, but all part of the same gravitational web. Spirals and ellipticals and irregulars all mingling together, their stars shining in a vast chorus of light. It would be overwhelming perhaps, but also deeply moving to see so many worlds gathered in one place. These clusters are like cities in the universe, densely populated regions separated by vast stretches of emptiness. And just as cities have their own character, so do galaxy clusters. Some are dominated by one or two giant elliptical galaxies, massive ancient structures that have grown by consuming smaller neighbours over billions of years. Others are more democratic, with no single galaxy standing out as dominant, just a crowd of equals bound by mutual attraction. The galaxies within a cluster do not remain still. They orbit around the cluster's centre of mass, moving through space at hundreds or even thousands of kilometres per second. But because the cluster is so large and the galaxies so far apart, collisions are rare. They pass by one another like ships in a vast ocean, close enough to feel each other's gravity, but far enough apart that actual contact almost never occurs. When it does, the result is a slow-motion merger, two galaxies blending over millions of years into a single new form. There is something deeply comforting in the idea of galaxy clusters, in knowing that even the grandest structures in the universe are held together by the same force that keeps our feet on the ground. Gravity is gentle, patient, working over immense timescales to gather matter into coherent forms. It does not force or rush. It simply pulls steadily and reliably, creating order out of chaos, connection out of isolation. Our local group is itself being drawn very slowly toward the Virgo cluster. We are part of a larger structure called the Virgo supercluster, a collection of galaxy groups and clusters all falling gently toward a common center. The motion is imperceptible on human timescales, but over billions of years, it will carry us closer, deepening our connection to that larger cosmic family. And beyond the Virgo supercluster, there are others, hundreds of them, scattered across the observable universe, each one a gathering of thousands or even millions of galaxies. These superclusters form the largest structures we know of, great filaments and walls of matter stretching across hundreds of millions of light years, separated by enormous voids where galaxies are rare. Together, these structures form a cosmic web, a pattern that reveals itself only when we step back and look at the universe as a whole. It is a pattern of connection, of relationship of galaxies and clusters and superclusters, all linked by gravity into one vast coherent whole. Nothing is truly separate. Everything belongs to something larger. As you lie here, now breathing slowly and deeply, imagine yourself as part of that web. You are on Earth, which orbits the Sun, which is part of the Milky Way, which is part of the local group, which is part of the Virgo supercluster, which is part of the observable universe. You are nested within layers of belonging, held by forces that have been at work since the beginning of time. There is no need to feel small in the face of this vastness. Instead, feel held, feel connected, feel part of a cosmic family that stretches across billions of light years and billions of years of time. You belong here as much as any galaxy does, as much as any star. And tonight, as you rest, the universe continues its slow dance. Galaxies orbiting one another, clusters drifting through the dark, everything moving together in a rhythm too grand for any one mind to fully comprehend, but beautiful nonetheless. Let that feeling of belonging settle over you, let it warm you, and let it carry you gently into sleep. Light is the fastest thing in the universe. Nothing can move more swiftly. In a single second, light travels far enough to circle the Earth more than 7 times. In 1 year, it crosses nearly 6 trillion miles of distance so vast, we give it a special name, a light year. And yet, even at this incredible speed, light takes an almost unimaginable amount of time to cross the distances between galaxies. Consider Andromeda, our nearest large galactic neighbour. The light we see from Andromeda tonight began its journey 2.5 million years ago. Think about that for a moment, without strain. Just let the number rest gently in your mind. 2.5 million years. The light has been travelling all that time, crossing the void between galaxies, moving at the fastest speed possible, and only now is it reaching your eyes. When that light left Andromeda, Earth was a very different place. There were no cities, no farms, no written language. Humans, as we know ourselves today, did not yet exist. Our early ancestors were just beginning to walk upright on the plains of Africa, learning to use simple tools, living lives we can barely reconstruct from the few fossils they left behind. The light from Andromeda has been travelling since before our species took its first conscious breath. This means that when we look at Andromeda, we are not seeing it as it is now. We are seeing it as it was long ago in the distant past. We are looking through time as well as space. The stars we see in that galaxy might have changed since their light began its journey. Some may have died, exploding as supernova, or fading quietly into darkness. Others may have been born, igniting from clouds of gas and dust. But we will not see those changes for millions of years, not until their light finally reaches us. Every galaxy is a time machine in this sense. The farther away a galaxy is, the farther back in time we see it. A galaxy 10 million light years away appears to us as it was 10 million years ago. A galaxy 1 billion light years away shows us what it looked like 1 billion years in the past, long before Earth had even formed, when the universe itself was younger and the stars were arranged differently across the sky. There is something both humbling and beautiful in this. We cannot see the present state of distant galaxies. We can only see their history preserved in light that has been travelling toward us across the expanding universe. The cosmos does not reveal itself all at once. It unfolds slowly, layer by layer, like the pages of a book being turned at the pace of light itself. Imagine standing outside on a clear night and looking up at the stars. Each point of light you see is a message from the past. The bright star Sirius, visible in winter, is about 8.5 light years away. The light you see left, that star 8.5 years ago, when you were younger perhaps, in a different place living a different chapter of your life. Betelgeuse, the red giant in Orion's shoulder, is over 600 light years distant. The light you see tonight has been travelling since before telescopes were invented, since before Galileo looked up at the sky. And those are just stars within our own galaxy. When we look at other galaxies, the distances stretch beyond easy comprehension. Millions of years, tens of millions, hundreds of millions. Some of the most distant galaxies we can see with our best telescopes are so far away that their light has been travelling for over 13 billion years, almost since the beginning of the universe itself. We are seeing them as they appeared when they were young, when the cosmos was still forming its first large structures. This does not make the universe feel empty or cold. Instead, it makes it feel rich with history, layered with time, full of stories that are still reaching us. We are surrounded by the past, by light that carries information about what the universe was like long before we existed. And in a very real sense, we are part of that past too, because the light leaving Earth right now will travel outward, potentially reaching other worlds billions of years from now, carrying an image of our planet as it is tonight. The universe is not just a place. It is also a timeline, a vast archive of moments stretching back to the earliest days after the Big Bang. And every observation we make, every photograph we take of a distant galaxy is a glimpse into that archive, a window into a time and place we can never visit except through the patient delivery of light. As you rest here, let yourself sit comfortably with this idea. You do not need to fully grasp the distances. No one can not really. Our minds are not built to hold such numbers in any meaningful way. But you can feel the poetry of it, the strange and beautiful fact that when we look outward into space, we are also looking backward through time. We are witnesses to the universe's history, receivers of messages sent long ago by stars and galaxies we will never touch, but can still see, still study, still wonder at. Let the thought settle gently. Light travelling for millions of years, carrying the image of a galaxy across the void, finally arriving here now, in this moment, meeting your gaze. It is a connection across time, fragile and profound, a reminder that even across impossible distances, we are not separate from the rest of the universe. We are part of its story, and it is part of ours. Breathe slowly. Let your body sink deeper into rest. The light from distant galaxies will continue its journey, whether you watch or not. And tonight, you can simply be here, held by the same time and space that holds everything else, drifting gently towards sleep. Imagine if you were floating in the space between galaxies, not near any stars, not within the comforting glow of a galactic disk, but truly between them in the vast stretches of intergalactic void. It is the quietest place you could ever be, the most profoundly silent, where the nearest star might be millions of light years away in any direction. At first, you might think this space is empty, a perfect vacuum, devoid of anything at all. But that is not quite true. Even here in the loneliest reaches of the universe, there is something. Scattered atoms of hydrogen drift slowly through the dark, so sparse that a handful of them might occupy a space the size of a room. They do not interact, do not collide, just exist in patient solitude, perhaps waiting billions of years before encountering another atom. There is also dust, though calling it dust makes it sound more substantial than it is. These are grains smaller than particles of smoke, bits of carbon and silicon and iron forged in ancient stars and expelled into space. They float here, suspended in the void, moving slowly under the gentle push of radiation pressure and the faint tug of distant gravity. They catch no light, reflect nothing, remain invisible in the endless dark. And there is light, though not the kind you would notice at first. It is not the light of stars or galaxies, but something older, something fainter. It is the afterglow of the Big Bang itself, the cosmic microwave background, a whisper of radiation that fills all of space. It has been travelling since the universe was very young, cooled now to just a few degrees above absolute zero, invisible to human eyes, but present nonetheless, a faint warmth in the cold. If you could stand here and possibly between two galaxies and look around, what would you see? The first thing you would notice is the darkness. Not the darkness of a moonless night on Earth, where stars still scatter across the sky, but a darkness deeper and more complete. The sky will be almost entirely black, empty of stars, empty of light, stretching in every direction without feature or form, but not quite empty. If you looked carefully, you would see two faint smudges of light, one in one direction, one in another. These would be the galaxies, your only neighbours in this vast emptiness. They would appear tiny, far smaller than the moon appears from Earth, just pale ovals glowing softly against the black. One might be a spiral, its arms barely visible. The other might be elliptical, a smooth lens of dim light. They would seem fragile, almost unreal, like memories of light rather than light itself. There would be no sense of motion, no way to tell that you were moving or that the galaxies were moving. Everything would appear frozen, suspended in time. Hours could pass, days, years, and nothing would seem to change. The galaxies would remain where they were glowing faintly, and the darkness would remain absolute. You would be adrift in a sea of stillness, where time itself seemed to slow to match the pace of the universe's expansion. The silence would be total, not just the absence of sound, but the absence of anything that could carry sound. No air, no medium, no vibrations. You could scream and hear nothing. You could clap your hands and feel no impact, no echo. It would be a silence so profound that it might feel like a presence, like something tangible pressing in from all sides. And yet paradoxically, there might be peace in that silence. No distractions, no noise, no chaos. Just existence in its purest form. Just you and the universe, stripped of everything but the most basic elements. It would be a place for contemplation, for stillness, for letting go of everything that usually fills the mind. A place where thoughts could drift like those sparse atoms of hydrogen, slow and unhurried, encountering each other, rarely leaving long spaces of emptiness in between. This is what lies between the galaxies. Not true emptiness, but something close to it. A quietness so deep, it feels sacred, a darkness so complete, it becomes a kind of canvas on which the galaxies shine like distant lanterns. It is a reminder that most of the universe is not filled with stars and planets and bustling activity. Most of the universe is this vast, still, patient waiting. We live in a galaxy surrounded by stars bathed in light, and so it is easy to forget that this is the exception, not the rule. The universe is mostly empty space, mostly silence, mostly darkness. But that darkness is not hostile. It is simply neutral and different, vast enough to hold everything without crowding, patient enough to endure for billions of years without complaint. As you lie here, now let yourself imagine that stillness, not as something frightening, but as something calming. A place where there is no rush, no pressure, no demands. Just existence, pure and simple. Just being without the need to do, or become, or achieve. The space between galaxies asks nothing of you. It simply is, and in its being, it offers a kind of peace that is hard to find anywhere else. Let your breath slow to match that stillness. Let your thoughts drift apart, like atoms in the void, each one separate, each one floating freely. There's no need to hold them together, no need to make sense of anything. Just let them be scattered and quiet, resting in the dark. And as the darkness of sleep begins to find you, as your body grows heavy and your mind grows soft, imagine yourself floating in that intergalactic space, held by nothing, surrounded by silence, with only the faint glow of distant galaxies to keep you company. It is a safe darkness, a gentle darkness, and it welcomes you now into rest. In April of 1990, a space shuttle carried something precious into orbit above Earth. It was a telescope named after Edwin Hubble, the man who had shown us that the universe was far larger than we had imagined. But this telescope would not sit on a mountaintop, peering through miles of turbulent atmosphere. Instead, it would float in the silence of space itself, above the air, above the weather, above everything that had ever blurred or distorted our view of the stars. The Hubble Space Telescope was not enormous by the standards of ground-based instruments. Its mirror was smaller than many others already in use. But its location changed everything. Without the atmosphere to scatter and distort light, Hubble could see with a clarity that had never been possible before. It could capture images of galaxies and nebulae with sharpness and detail that seemed almost unreal, as if someone had opened a window to the cosmos and invited us to look through. The first images took time to arrive. Hubble had to be calibrated, adjusted its instruments, tested and refined. And when those first pictures were released to the world, people looked at them and fell silent. Here were galaxies rendered in such exquisite detail that you could see individual star clusters within them. Here were nebulae glowing in colours so vivid they seemed painted vast clouds of gas and dust lit from within by newborn stars. Here was the universe, as it truly was not filtered through the veil of Earth's atmosphere, but direct and unmediated. One of the most striking things about Hubble's images was how beautiful they were. Of course, beauty is not a scientific measurement. It does not add to our understanding in any quantifiable way, but it matters nonetheless. When people saw Hubble's photographs of the pillars of creation, towering columns of gas in the Eagle Nebula, where stars were being born, they did not think first about the physics or the chemistry. They thought about how it looked like the hand of something divine reaching into space. They felt awe, and that awe made them care about the universe in a way that numbers alone never could. Hubble began to explore the sky, systematically pointing its lens at one region after another, capturing light from galaxies near and far. And almost everywhere it looked, it found galaxies. Not just a few scattered here and there, but thousands, tens of thousands, filling the frame in every direction. Patches of sky that had seemed empty through ground-based telescopes turned out to be crowded with faint galaxies, each one a distant island of stars, billions of light years away. The telescope worked day and night, or rather orbit after orbit, since in space there is no day or night in the way we experience them on Earth. It circled the planet every 90 minutes, moving through darkness and sunlight, its instruments constantly recording data, its sensors capturing photons that had travelled unimaginable distances to reach it. And back on Earth, astronomers received that data, processed it, turned it into images and shared it with the world. Each image was like a gift, a spiral galaxy seen face on its arms glowing blue with young stars. An elliptical galaxy, serene and ancient, surrounded by a halo of faint light. Two galaxies in the process of colliding, their shapes distorted by gravity, their stars mingling in a slow cosmic dance. A distant quasar, blazingly bright despite being billions of light years away, powered by a supermassive black hole at its core. And people began to see the universe not just as a subject of scientific study, but as something worth appreciating for its own sake. Hubble's images appeared in magazines, on posters in classrooms and living rooms. They became part of the culture, a shared visual language for wonder. Children grew up with pictures of galaxies on their walls, and perhaps some of them were inspired to become astronomers themselves, to continue the work of exploring and understanding. There was something almost meditative about looking at Hubble's images. They invited you to stop, to pause, to simply be present with the beauty and strangeness of what you were seeing. A galaxy is not a static object. It is a dynamic system full of motion and change, even though that change happens over timescales far longer than a human life. But in Hubble's photographs, you could see that dynamism frozen in a single moment, like a dancer captured mid-leap, all grace and energy suspended in stillness. The telescope also deepened our understanding in ways that went beyond aesthetics. By observing distant supernovae, Hubble helped astronomers discover that the universe's expansion is accelerating, driven by a mysterious force now called dark energy. By studying the light from ancient galaxies, it revealed how galaxies have evolved over billions of years, growing from small, irregular clumps into the grand spirals and ellipticals we see today. Every observation added another piece to the puzzle, another detail to the story of how the universe came to be the way it is. But perhaps the most profound contribution Hubble made was simply to show us again and again that the universe is beautiful, that it is worth looking at, worth caring about, worth protecting. In an age where we face so many challenges here on Earth, Hubble reminded us that we are part of something larger, something ancient and vast and filled with wonders we are only beginning to explore. As you rest here now, imagine one of Hubble's images, a galaxy perhaps glowing softly against the black of space, its spiral arms traced in light, its core bright and warm. Or a nebula billowing like clouds lit by sunset colours that seem impossible, but are real, captured by senses more sensitive than human eyes. Let the beauty of these images wash over you, not as something to analyse or understand, but simply as something to feel. The universe, as Hubble showed us, is not cold or hostile. It is radiant with light, structured with grace, filled with forms that stir something deep within us. And tonight, as you drift towards sleep, you can carry that beauty with you, a gentle reminder that we live in a cosmos worth wondering at, worth exploring, worth celebrating in quiet moments like this. Let the images fade now. Let your mind grow soft and still. The universe will continue to shine, and Hubble will continue its orbit patient and tireless, sending back its gifts of light. And you here in the warmth and dark can simply rest. In December of 1995, astronomers made a decision that seemed to some almost reckless. They would point the Hubble Space Telescope at a tiny patch of sky that appeared completely empty. No bright stars, no known galaxies, just darkness. And they would leave it pointed there for 10 days, letting the camera gather every single photon of light that reached it from that small, seemingly barren region. 10 days is a long time for a telescope as valuable as Hubble. There were thousands of astronomers around the world waiting to use its proposals for observations that would study known objects' familiar targets. But the team believed that looking at nothing might reveal something extraordinary. They believed that the universe was deeper than we had yet imagined, and that if we looked long enough, even at the emptiest places, we would find galaxies hiding in the dark. The patch of sky they chose was tiny, about the size of a grain of sand held at arm's length. If you stood outside and looked up, you could cover it with the smallest pinprick. It was a piece of sky so small that most people would never notice it, a region that contained, as far as anyone knew, absolutely nothing of interest. But Hubble looked. Orbit after orbit, the telescope kept its gaze fixed on its spot-gathering light. Photons that had travelled for billions of years across the expanding universe finally reached Hubble's mirror, were focused by its optics and recorded by its sensors. One by one, image after image, the exposure grew longer, the data accumulated, and astronomers on Earth waited to see what would emerge. When the final image was processed and revealed, there was a collective intake of breath. The patch of sky was not empty at all. It was filled with galaxies. Nearly 3,000 of them, scattered across the frame like jewels on black velvet. Some were large and clear, their spiral arms visible, their shapes distinct. Others were tiny, faint smudges of light, barely more than a few pixels galaxies. So distant, their light had been travelling since the universe was young. Each one of those tiny points of light was not a star, but an entire galaxy. Each one contained hundreds of billions of stars, perhaps trillions of planets, entire worlds and systems and possibilities beyond counting. And this was just one small patch of sky, one grain of sand's worth of the cosmic sphere. If this tiny region contained 3,000 galaxies, how many must there be in the entire observable universe? The number was staggering. If you could take similar deep images of every part of the sky, you would find not millions of galaxies, but hundreds of billions, perhaps even trillions. The universe was not just large, it was incomprehensibly vast. So filled with galaxies that almost anywhere you looked, no matter how empty a region seemed, you would find them hiding in the darkness, waiting for patient eyes to see them. The Hubble Deep Field, as the image came to be called, changed the way we thought about our place in the cosmos. It was one thing to know intellectually that the universe was large. It was another to see in a single image just how crowded it was with galaxies, how abundant and various they were. Spirals and ellipticals and irregulars, some near, some impossibly far, some interacting with neighbours, others drifting alone. Every shape, every size, every stage of galactic life represented in that one small window. There was a humility that came with seeing that image. We had thought we were beginning to understand the universe, that we had catalogued most of the nearby galaxies and were filling in the gaps. But the Hubble Deep Field showed us that we had barely begun. There were so many more galaxies than we had counted, so many more stories yet to discover, so much more universe than we had accounted for. And yet paradoxically, the image was also comforting. Yes, we were small. Yes, our galaxy was just one among countless others, and our planet was a tiny speck within that galaxy. But we were also part of this magnificent abundance. We belonged to a universe so rich with structure, so full of light and form, that even the emptiest seeming patches of sky revealed wonders when examined closely enough. The deep field became iconic, reproduced in textbooks and documentaries, analysed by scientists and admired by the public. People stared at it, trying to comprehend what they were seeing, trying to wrap their minds around the scale of it. Some found it overwhelming, the sheer number of galaxies, almost too much to process. Others found it inspiring, a reminder that the universe was far more interesting than we had dared to hope. Astronomers continued to create even deeper images in the years that followed. The Hubble Ultra Deep Field, the Extreme Deep Field, each one looking even farther back in time, revealing even fainter galaxies, pushing the boundaries of what could be seen. But the original deep field remained special because it was the first time humanity truly understood just how populated the universe was. As you lie here now, imagine that image in your mind, not in sharp detail, but as a feeling, an impression. A dark field scattered with light, each point a galaxy, each galaxy a world of stars. So many of them, so quietly present, glowing in the dark, and all of it captured in a space smaller than a grain of sand held at arm's length. Let that image settle gently over you, not as something to study or analyze, but as something to rest with. The universe is vast, yes, but it is also full of galaxies, full of stars, full of light that has been traveling for unimaginable stretches of time to reach us. And somewhere in that vastness, you are here, part of it all, as real and present as any of those distant galaxies. There is no need to understand it completely. No one does. But you can feel it, the quiet presence of all those galaxies, the patient shining of all that light. And as you feel it, as your breath slows and your body grows heavy, let yourself be held by that vastness, not overwhelmed by it, but cradled by it, resting in the knowledge that the universe is far larger and more beautiful than we will ever fully comprehend. Let the deep field fade now into the background of your thoughts. Let its galaxies become soft points of light in your mind's eye, distant and gentle. And let yourself drift peacefully into the deep field of sleep. After the Hubble Deep Field revealed thousands of galaxies in a patch of sky, no larger than a grain of sand, astronomers faced a question both simple and profound. If there were that many galaxies in such a tiny region, how many galaxies existed in the entire observable universe? It was a question that demanded an answer. But finding that answer would require patience, careful mathematics, and a willingness to work with numbers almost too large to comprehend. You cannot count galaxies the way you might count stars visible on a clear night, pointing to each one and adding it to a tally. There are far too many scattered across distances, too vast, many of them, too faint to see, even with the most powerful telescopes. Instead, astronomers had to be clever. They had to sample the universe, choosing representative regions, counting the galaxies there, and then extrapolating outward to estimate the total. It is a method similar to how you might estimate the number of trees in a vast forest. You cannot walk to every tree and count it, not if the forest stretches for thousands of miles. Instead, you choose several plots of land scattered throughout the forest, count the trees in each plot, calculate the average density, and then multiply by the total area of the forest. The result is an estimate, not a perfect count, but close enough to give you a sense of the forest's scale. Astronomers did something similar with galaxies. They selected patches of sky in different directions, some near the galactic poles where our own Milky Way does not obscure the view, others in regions known to be relatively free of foreground stars. They pointed Hubble and other telescopes at these patches, took deep images, and counted every galaxy they could see. Then they measured the area of sky they had observed, compared it to the total area of the entire celestial sphere, and multiplied. The mathematics was straightforward, but the implications were dizzying. Based on images like the Hubble Deep Field and similar observations, astronomers in the late 1990s arrived at an estimate. There were somewhere between 100 billion and 200 billion galaxies in the observable universe. 100 billion at minimum, perhaps twice that, maybe more. The exact number was uncertain, but the scale was clear. The universe was filled with galaxies in numbers almost beyond imagination. 100 billion is not an easy number to hold in your mind. If you tried to count to 100 billion, spending just 1 second on each number, it would take you more than 3,000 years. If every person on Earth counted one galaxy, we would not even come close to covering them all. The number is so large, it becomes abstract a symbol rather than a quantity you can truly feel. But astronomers did not stop there. They knew their estimate was rough based on assumptions about how galaxies were distributed and how many faint galaxies their telescopes might be missing. As technology improved and observations became more sensitive, it became clear that there were even more galaxies hiding in the darkness than they had first thought. Smaller galaxies, fainter galaxies, galaxies so distant that their light had been stretched by the expansion of the universe into wavelengths almost invisible. Still, for many years, the estimate of 1 to 200 billion galaxies remained the standard answer. It was the number cited in textbooks, repeated in documentaries, shared with students learning about the cosmos. And while it was an estimate, while it carried uncertainty, it was close enough to give us a sense of scale to help us understand that the universe was not just large, but populous beyond reckoning. There was something both humbling and exhilarating about that number. Humbling because it meant our galaxy, our home, was just one among 100 billion others, a single drop in an ocean of light. Exhilarating because it meant the universe was so much richer, so much more full of possibility than we had allowed ourselves to imagine. Every one of those galaxies was a world, a collection of stars and planets, and perhaps life, each one with its own history, its own character, its own place in the cosmic story. And yet the number was only an estimate. The universe does not come with a label listing its contents. We cannot see every galaxy, cannot measure every distance perfectly, cannot account for every faint smudge of light hiding in the data. All we can do is observe carefully, calculate thoughtfully, and acknowledge the limits of our knowledge. The estimate might be too low, or it might be too high, or it might be just right. We do not know for certain, and perhaps we never will. But that uncertainty is part of the beauty. Science is not about claiming perfect knowledge. It is about approaching the truth, gradually refining our understanding one observation at a time, remaining open to the possibility that the universe might surprise us yet again. And it would, as we will see. The estimate of 1 to 200 billion galaxies would not stand forever. New observations, new techniques, new insights would reveal that the universe held even more than we had thought. For now, though, let us simply rest with the number as it was understood in those years. 100 billion galaxies, perhaps 200 billion, scattered across the observable universe like seeds scattered across an infinite field. Each one a beacon of light, each one a world unto itself, each one part of the grand tapestry of existence. As you lie here, breathing slowly, let that number settle gently in your mind, not as something to analyze or memorize, but as something to feel. 100 billion galaxies, so many worlds, so much light, so much space for wonder and discovery. And you are here, part of it, all connected to every one of those distant islands of stars by the same laws of physics, the same threads of gravity, the same cosmic story that began billions of years ago and continues still. Let the number fade now. Let it become soft and indistinct, like the galaxies themselves when seen from a great distance. There is no need to hold onto it tightly. It is enough to know that the universe is vast, that it contains more galaxies than we can easily count, and that each one of them is shining quietly in the dark, waiting to be seen, waiting to be understood. And as that knowledge settles over you, like a gentle weight as your breath slows and your thoughts begin to drift, let yourself feel the peace that comes with knowing you're part of something larger. Not lost in it, not diminished by it, but held by it, cradled by the same vastness that cradles all those distant galaxies. Rest now in that vastness, and let sleep come softly. When we look at distant galaxies, we are not simply seeing things far away in space. We are also seeing them as they were long ago in the deep past, when the universe itself was younger. Light takes time to travel, and the farther it must journey, the longer that journey takes. So every observation of a distant galaxy is also a glimpse backward through time, a window into an earlier chapter of cosmic history. The most distant galaxies we can see are so far away that their light has been traveling toward us for more than 13 billion years. Think about that for a moment, gently without strain. 13 billion years. The light we see from these galaxies began its journey when the universe was less than 1 billion years old, when it was still young, still forming its first large structures, still learning how to be itself. At that time, Earth did not exist. Our sun had not yet been born. The Milky Way was not yet the grand spiral we know today, but perhaps a smaller collection of stars and gas still gathering itself together. The universe was a different place, then simpler in some ways, more chaotic in others, and the galaxies that existed at that time looked nothing like the galaxies we see nearby today. When astronomers study these ancient galaxies, they notice something striking. They are smaller, more irregular, less organized. They do not have the elegant spiral arms or smooth elliptical forms of mature galaxies. Instead, they appear clumpy, fragmented, almost haphazard, as if they are still in the process of figuring out what shape they will take. They are galaxies in their infancy, cosmic toddlers, stumbling through their first steps. These early galaxies also burn more brightly with the blue light of young, hot stars. Star formation was vigorous back then, with gas collapsing rapidly into new suns, igniting in bursts of activity that lit up the young universe. There was an energy to those galaxies, a rawness, a sense that everything was happening quickly, intensely, without the measured patience that comes with age. Observing these distant galaxies is not easy. They are incredibly faint, their light stretched and reddened by the expansion of the universe, which carries them away from us at tremendous speeds. Astronomers must use the most sensitive instruments, taking exposures that last for days, gathering every possible photon. And even then, the galaxies appear as little more than smudges, faint blurs of light that require careful analysis to reveal their properties. But the effort is worth it, because these observations show us where we came from. The Milky Way, like all large galaxies, began as one of these small, chaotic systems. Over billions of years, it grew, merging with other small galaxies, pulling in gas from the surrounding space, gradually organizing itself into the structure we see today. The process was slow, patient, spanning timescales so long that even stars are born and die within them. When you look at an image of a distant galaxy, you are seeing not just that galaxy, but a moment in time. You are seeing the universe as it was when it was young, still full of potential, still shaping itself. And in a very real sense, you are looking at your own history, because the atoms that make up your body were forged in stars that existed in galaxies, like those stars that lived and died, and scattered their material into space material that eventually found its way into the cloud that formed our sun and planets. There is a poignancy to these observations, a strange mix of wonder and melancholy. We are seeing these galaxies as they were billions of years ago, but we will never see them as they are now. The light showing the current state will not reach us for billions more years. And by then, if anyone is still here to see it, Earth and everything on it will have changed beyond recognition. We are separated from these galaxies, not just by space, but by time, and that separation is absolute. Yet there is also comfort in knowing that the universe has a history, that it has grown and evolved, that it was once different and will one day be different again. Nothing is static, nothing is permanent. Even galaxies, those vast islands of stars that seem eternal, are born, mature, and eventually fade. The universe is a story unfolding across billions of years, and we are fortunate enough to be here in this chapter, able to look back and catch glimpses of earlier chapters preserved in light. Astronomers continue to push deeper, searching for even more distant galaxies, trying to see back to the very first ones that formed after the Big Bang. These earliest galaxies are the ancestors of everything we see today, the seeds from which the cosmic web grew. Finding them, studying them, understanding how they formed is like reconstructing the roots of a great tree, tracing the branches back to their origin. And what they find is humbling. The first galaxies were tiny, perhaps just a few million stars, nothing like the billions of stars in a modern galaxy. They flickered to life in the darkness, illuminating the universe for the first time since the Big Bang's initial glow had faded. They were the first lights in the cosmic night, and their existence marked the beginning of the universe as we know it, full of stars and planets, and the possibility of life. Seeing these ancient galaxies, even as faint blurs in a telescope image, is like looking at baby pictures of the universe. There is a tenderness to it, a recognition that everything has a beginning, that even the grandest structures were once small and fragile. And just as we might look at a photograph of ourselves as children and feel a mix of nostalgia and gratitude for how far we have come, we can look at these distant galaxies and feel grateful for the long, slow process that eventually led to us being here, able to observe and wonder. As you rest here now, let yourself sit with that feeling. The universe was once young, and in a sense, it still is. 13 billion years sounds like a long time, and it is, but the universe may exist for trillions of years, more cooling and expanding stars forming, and dying galaxies drifting farther and farther apart. We are witnessing a moment in that vast span, a single breath in a story that has no clear ending. Let the image of those distant ancient galaxies rest gently in your mind. Small, bright, chaotic, full of the energy of youth. And let yourself feel connected to them, knowing that the atoms in your body carry their legacy, that you are made of star stuff that has been cycling through the universe since those early days, transforming, reforming, endlessly becoming something new. Breathe slowly now. Let your thoughts drift like those ancient photons, traveling across vast distances, carrying their messages from the past. And as you drift, as your body grows heavy and your mind grows quiet, let yourself be held by the knowledge that you are part of this long story, this cosmic unfolding. You belong to it, and it belongs to you. Rest now in the stillness, in the quiet, in the gentle embrace of time and space. The distant galaxies will continue their journey, and so will you. But for now, there is only this moment, this breath, this soft descent into sleep. For years, astronomers had lived with the estimate that there were somewhere between 100 billion and 200 billion galaxies in the observable universe. It was a number so large, it seemed almost impossible to improve upon a figure that had become familiar through repetition, printed in textbooks and spoken in lectures. But science does not stand still. New instruments bring new data and new ways of analysing that data can reveal things previously hidden. In 2016, a team of astronomers decided to look again at the question of how many galaxies exist. They took data from Hubble and other telescopes, including observations that had been made over many years, and applied new mathematical models to account for galaxies that were too faint or too distant to be seen directly. They wanted to know not just how many galaxies we could see, but how many were truly out there, including those hiding in the darkness beyond our current ability to detect them. The process was painstaking and required sophisticated computer simulations. The team had to estimate how galaxies were distributed across space, how their numbers changed with distance, and how many small, faint galaxies existed for every large, bright one. They accounted for the fact that our telescopes could only see a fraction of what was actually there, that for every galaxy we could detect, there might be many more lurking just below the threshold of visibility. When their calculations were complete, the result was startling. The number of galaxies in the observable universe was not 100 billion, not 200 billion, but closer to 2 trillion, 2,000 billion, 10 times more than previous estimates had suggested. The universe, it turned out, was far more crowded with galaxies than anyone had realized. 2 trillion is a number that resists comprehension. If you tried to count to 2 trillion, spending just 1 second on each number, it would take you more than 60,000 years. If every person who has ever lived on Earth counted one galaxy, we would still fall short. The number is so vast, it becomes almost meaningless as a quantity, transforming instead into a symbol of abundance, of plenitude, of a universe overflowing with structure and light. What made this new estimate so surprising was not just its size, but what it implied. If there were 2 trillion galaxies, and each galaxy contained hundreds of billions of stars, then the total number of stars in the universe was beyond any number we could meaningfully express. And if even a tiny fraction of those stars had planets, and even a smaller fraction of those planets were capable of supporting life, the possibilities became almost overwhelming. The revision did not come from discovering new galaxies in the traditional sense. Most of the additional galaxies were small, faint, and distant, too dim to appear in even the deepest images we had taken. But by understanding how galaxies formed and evolved, by modeling their distribution mathematically, astronomers could infer their presence. It was like knowing there must be countless grains of sand on a beach, even if you can only see a handful at your feet. This discovery did not overturn what we knew about the universe. It simply refined it, deepened it, added another layer of detail to our understanding. The laws of physics remained the same. The story of cosmic evolution remained unchanged. But the scale of that story, the sheer number of actors performing in it, had suddenly expanded by a factor of 10. There was something both humbling and exhilarating about this revelation. Humbling because it reminded us once again how much we still didn't know, how easily our estimates could be off by such enormous margins. We had thought we were getting close to a final answer, and then the universe surprised us, revealing that it held far more than we had accounted for. It was a lesson in humility, a reminder that no matter how much we learn, there is always more to discover. But it was also exhilarating because it meant the universe was richer, more complex, more full of possibility than we had dared to imagine. 2 trillion galaxies, each one a world of stars, each star potentially surrounded by planets, each planet a stage on which the drama of existence might unfold. The odds of finding life elsewhere, of discovering that we are not alone, suddenly seemed a little less remote. Astronomers responded to this new number with a mixture of excitement and caution. Excitement because it opened new questions, new avenues of research, new challenges to tackle. Caution because estimates are only as good as the assumptions they rest on, and there was still much uncertainty in the models. The true number might be higher, or it might be lower. The universe does not reveal its secrets easily or all at once. But regardless of the exact figure, the message was clear. The universe is vast beyond imagining, and it is filled, densely filled with galaxies. Everywhere we look, in every direction, galaxies stretch away into the distance layer upon layer, receding toward the edge of the observable cosmos. And even at that edge, there are likely more galaxies beyond invisible to us, not because they do not exist, but because their light has not yet had time to reach us. As you lie here, breathing slowly, let this new number settle over you. Not as a burden, not as something to hold tightly, but as a gentle weight, a reminder of how much exists beyond your immediate experience. 2 trillion galaxies. More than you will ever see, more than anyone will ever count, more than the mind can fully grasp. And yet, they are there shining quietly in the dark, each one real, each one part of the same universe you inhabit. There is no need to understand it fully. No one does. But you can rest in the knowledge that the universe is abundant, that it overflows with galaxies and stars and possibilities. And in that abundance, you are not diminished. You are not lost. You are simply one part of a whole so vast and intricate that its full beauty can never be seen by any single observer, but only hinted at, glimpsed in fragments, appreciated in moments like this. Let the number fade, now becoming soft and indistinct. 2 trillion galaxies drifting through space, each one following its own path, each one part of the cosmic dance. And as they drift, as the universe continues its slow expansion, you can rest here, held by the same forces that hold them, breathing the same atoms that were forged in their stars, connected to everything part of it all. Breathe deeply now. Let your thoughts grow quiet. Let your body sink into stillness. The galaxies will continue their journey, patient and unhurried, and you can continue yours, descending gently into the peaceful darkness of sleep, where numbers do not matter, where distance dissolves, and where you can simply be resting in the quiet heart of the universe. On Christmas Day in 2021, a rocket lifted off from French Guiana, carrying the most powerful space telescope ever built. It was called the James Webb Space Telescope, named after an administrator who had helped guide NASA through its early years. But this telescope was not bound for low Earth orbit like Hubble. Instead, it would travel nearly 1 million miles away to a special point in space where the gravitational pulls of Earth and Sun balance, allowing it to remain stable with minimal effort. The journey took a month, and during that time, the telescope slowly unfolded like an impossibly delicate origami sculpture. Its mirror, made of 18 hexagonal segments, coated in gold, spread open to collect light. Its sun shield, as large as a tennis court, unfurled in layers to protect the instruments from the heat of the sun. Everything had to work perfectly. There would be no way to send astronauts to repair it if something went wrong. But piece by piece, the telescope assembled itself, and eventually, it was ready. James Webb was designed to see what Hubble could not. While Hubble observed primarily invisible light, the kind our eyes can see, Webb would look in infrared, detecting heat rather than light. This might seem like a small difference, but it changed everything. Infrared light can pass through dust clouds that block visible light, revealing stars being born in hidden nurseries. And crucially, infrared can see the most distant galaxies whose light has been stretched by the expansion of the universe into wavelengths too long for Hubble to detect. For months after its arrival in space, Webb was tested and calibrated its instruments, carefully adjusted to ensure they were working as intended. Astronomers around the world waited with quiet anticipation. They had spent decades planning observations, proposing projects, hoping for the chance to use this extraordinary tool. And finally, in July of 2022, the first images were released to the public. The response was immediate and profound. People looked at the images and fell silent, struck by their clarity, their depth, their sheer beauty. One image showed a cluster of galaxies acting as a gravitational lens, their combined mass bending the light from even more distant galaxies behind them, creating arcs and streaks of light that trace the curvature of space itself. And scattered throughout the image, in every direction, were galaxies. Hundreds of them, maybe thousands, each one a distinct smudge or spiral or ellipse, each one billions of light years away. Another image captured a region of space called the cosmic cliffs, part of a star-forming nebula where gas and dust were being sculpted by stellar winds into shapes that looked almost like landscapes, cliffs and valleys, and mountains made of glowing vapor. And here too, in the background, galaxies appeared faint and distant, photobombing the foreground spectacle with their quiet presence. What struck people most was not just the scientific value of these images, though that was immense, but their aesthetic power. They were hauntingly beautiful, painted in colours that corresponded to different wavelengths of infrared light, translated into visible hues for human eyes. Deep reds and oranges, brilliant blues and whites, all swirling together in compositions that seemed almost intentional, as if the universe had arranged itself to be pleasing to the eye. James Webb began its work, in earnest observing galaxies at the edge of the observable universe galaxies. So distant, their light had been travelling for more than 13 billion years. And what it found was surprising. These early galaxies were brighter and more structured than models had predicted. Some of them seemed to have formed stars more quickly than should have been possible, challenging our understanding of how galaxies grew in the universe's infancy. It was a reminder that the cosmos still held secrets, that our theories, no matter how well tested, might need revision in the face of new evidence. The telescope also studied nearby galaxies in exquisite detail, revealing structures within them that Hubble could only hint at. Individual star clusters, dust lanes, regions of active star formation, all rendered with a precision that allowed astronomers to ask new questions and pursue new lines of inquiry. Every observation added to the tapestry of knowledge, filling in gaps, raising new puzzles, deepening the mystery, even as it clarified the details. There was something hopeful about Webb's observations, a sense that we were entering a new chapter in our exploration of the universe. For decades, Hubble had been our primary eye in the sky, and it had served us well, revealing wonders we had never imagined. But now Webb was taking us further, showing us things that had been invisible before pushing the boundaries of the observable cosmos outward. And with each new image, each new discovery, we were reminded that there is always more to see, more to learn, more to wonder at. The telescope continues its work, night after night, orbit after orbit, gathering light from the farthest reaches of space. Astronomers submit proposals for observations, waiting months or years for their turn to use Webb's instruments. Every second of observing time is precious, allocated carefully to ensure the most scientifically valuable projects are prioritized. But even in its busiest moments, Webb operates with a kind of patience, a quiet persistence, slowly accumulating data that will be analyzed for decades to come. As you rest here now, imagine the telescope floating in space far from Earth, its golden mirror turned toward the stars. It is silent out there, no sound to accompany its observations, just the steady collection of photons arriving after journeys lasting billions of years. And those photons, once captured, are turned into images that we can see, stories we can read, glimpses of the universe's history preserved in light. There is something comforting in knowing that this work continues, that even while you sleep, telescopes are observing, astronomers are analysing, our understanding is growing. The universe does not demand that we watch it every moment. It is patient, enduring, willing to wait for us to catch up. And when we are ready, when we turn our attention skyward, it reveals a little more of itself, inviting us deeper into its mysteries. Let the image of James Webb settle gently in your mind, a telescope floating in the darkness, looking back toward the beginning of time, seeing galaxies as they were when the universe was young. And let yourself feel connected to that endeavour, to the human impulse to explore, to understand, to see what lies beyond the horizon. It is an impulse as old as our species, and it continues still carried forward by instruments like Webb, by the curiosity of scientists, by the wonder of people like you who pause to ask questions about the cosmos. Breathe slowly now. Let your thoughts drift like light across space, travelling vast distances, carrying their own messages. And as you drift, as sleep begins to find, you know that the universe is still out there, still revealing itself, still waiting with infinite patience for the next question, the next observation, the next moment of discovery. But tonight, you can rest. The universe will keep its secrets a little longer. And when you wake, it will still be there, ready to be wondered at once more. After all these centuries of observation, after all the telescopes built and images captured, after all the careful counting, and mathematical modelling, we still do not know exactly how many galaxies exist in the universe. The estimate of 2 trillion is the best we have, but it remains just that an estimated number arrived at through extrapolation and assumption, not through direct counting. And there is a good chance it is still too low. There are galaxies too faint for our telescopes to see, even with long exposures and sensitive instruments. Small dwarf galaxies containing only a few million stars instead of billions glow so dimly that they vanish into the background noise of the sky. They are there orbiting larger galaxies or drifting alone through the voids, but they remain invisible to us, hiding in plain sight, simply because they do not shine brightly enough to be detected across vast distances. And then there are the regions of space we have not yet observed in detail. The universe is vast, and even with decades of work by Hubble and Webb and countless other telescopes, we have only studied small portions of it carefully. Much of the sky remains unexamined at the deepest levels, and within those unexplored regions, there are surely galaxies waiting to be discovered, each one adding to the total count, each one a reminder that our surveys are incomplete. Beyond the observable universe, there may be even more. The observable universe is limited not by the universe's actual size, but by the fact that light has only had a finite amount of time to reach us since the Big Bang. There may be galaxies so far away that their light has not yet arrived, galaxies that exist but remain forever beyond our ability to see. We cannot count what we cannot observe, and so the true number of galaxies in the entire universe, if it is indeed infinite, may be uncountable in the most literal sense. This uncertainty is not a failure of science. It is simply the nature of exploring something as vast as the cosmos. We do our best with the tools we have. We make educated guesses based on the data we can gather, and we remain open to the possibility that we are wrong, that the universe holds more than we have accounted for. There is humility in that openness, a recognition that we are small creatures trying to understand something immeasurably large, and that our understanding will always be partial, always incomplete. But there is also something wonderful about this uncertainty. It means the universe still has the power to surprise us. It means there are still discoveries waiting to be made, still questions without answers, still mysteries that will occupy future generations of astronomers. The work is not finished. It may never be finished. And that is not a cause for frustration, but for celebration. Imagine a universe where we knew everything, where every galaxy had been catalogued, every distance measured, every question answered. It would be a smaller universe in some fundamental way, not in physical size, but in the space it left for wonder. The unknowing, the not yet discovered, the mysterious. These are what keep us looking up, what keep us asking questions, what keep us engaged with the cosmos in a way that goes beyond mere academic interest. The universe does not owe us answers. It does not present itself neatly packaged and explained. It simply is vast and complex and filled with structures we are only beginning to understand. And part of the beauty of that is accepting that we will never see the whole picture, never hold the complete map, never count every star and every galaxy and every planet. We can only ever see a portion, and even that portion is mediated by the limitations of our instruments and the constraints of the speed of light. So when we say there are 2 trillion galaxies, we say it with a quiet qualifier in mind. At least 2 trillion, probably more, maybe many more. The number is not fixed, it is not final. It is a marker along the path of discovery, a signpost indicating how far we have come, but not claiming to show the destination. And that is as it should be. The universe is not a puzzle to be solved once and then set aside. It is an ongoing conversation, a relationship that unfolds over time, revealing new facets as we learn to ask better questions and build better tools. Each generation adds to the knowledge, refines the estimates, pushes the boundaries a little further. And each generation also passes on a sense of wonder, a recognition that no matter how much we learn, there will always be more waiting, just beyond the edge of the known. As you lie here now, breathe in slowly. Let yourself rest in that not knowing. You do not need to understand everything. You do not need to have all the answers. It is enough to know that the universe is large, that it contains more galaxies than we can count with certainty, and that each one of those galaxies is a world unto itself, full of stars and possibilities we may never fully comprehend. There is peace in that acceptance. The universe does not demand that you understand it. It does not ask you to solve its mysteries or memorize its numbers. It simply invites you to look, to wonder, to feel the quiet awe that comes with recognizing how much exists beyond your immediate experience. And tonight, that is enough. Let the unknowing settle over you like a soft blanket. Let it comfort rather than trouble you. The universe holds its secrets gently, patiently, without urgency. And you can do the same, holding your questions lightly, allowing them to exist without needing immediate answers, resting in the space between knowing and not knowing where wonder lives. Breathe deeply. Let your body sink into stillness. The galaxies will continue the dance whether we count them or not. And you can rest here, part of the same universe, held by the same forces, drifting gently into sleep. 2 trillion galaxies. Let that number rest quietly in your mind for a moment, not as something to calculate or analyze, but simply as a presence, a weight, a reminder of scale. 2 trillion islands of stars scattered across the observable universe, each one containing hundreds of billions of suns, perhaps more. The mathematics becomes overwhelming quickly, numbers stacking upon numbers until they lose all connection to ordinary experience. But let us think about it differently, more gently. Each of those galaxies is a place, not an abstract collection of statistics, but a real location in space where stars burn and planets orbit, and perhaps somewhere life exists. Each galaxy has a center and edges spirals or spheres of light, regions dense with stars, and regions nearly empty. Each one has been evolving for billions of years, forming and reforming, creating and destroying, following the slow rhythms of cosmic time. And within each galaxy, there are stars beyond counting. If a typical galaxy contains 100 billion stars and there are 2 trillion galaxies, then the total number of stars becomes a figure so large it has no meaning in human terms. It is simply abundance plenitude, an overflowing of light and energy across the cosmos. And around many of those stars, perhaps most of them, orbit planets. We are beginning to discover just how common planets are. Nearly every star we study closely seems to have them, sometimes 1 or 2, sometimes a whole family, circling in nested orbits. Some are gas giants, others rocky worlds, some scorched by their sun's heat, others frozen at the edge of darkness. And among all those planets spread across 2 trillion galaxies, how many might have conditions suitable for life? We do not know. We cannot know, not yet. But the sheer number of possibilities is staggering. If even a tiny fraction of planets can support life, and even a smaller fraction actually develops it, the universe could be teeming with living things. Microbes in subsurface oceans, forests swaying under alien skies, creatures we cannot imagine because they evolved in environments completely unlike Earth. The odds seem to favor life existing somewhere out there, perhaps in many places, perhaps in more places than we can count. And perhaps on some of those distant worlds, there are beings capable of looking up at their own night sky and wondering. Perhaps they have built their own telescopes, conducted their own surveys, asked their own questions about how many galaxies exist. Perhaps they too have felt small and awed and humbled by the vastness they discovered. Perhaps in this very moment, someone on a planet orbiting a star in a galaxy billions of light years away is lying down just as you are thinking about the cosmos, feeling connected to something larger. We will probably never meet them. The distances are too great, the speed of light too limiting. Even if we sent a message today, traveling at light speed, it would take millions or billions of years to reach most galaxies. And by the time any reply arrived, humanity as we know it might no longer exist. We are separated by gulfs of space and time, that may be fundamentally unbridgeable. And yet the possibility of their existence changes something. It means we are not alone, not the only witnesses to the universe, not the only ones asking questions. There is comfort in that thought, not the loneliness of being the only conscious beings in a vast, empty cosmos, but the quiet companionship of knowing that somewhere, perhaps in many somewheres, others are looking up, just as we do, wondering, just as we wonder, feeling the same mixture of smallness and connection that comes from contemplating the stars. This does not diminish us. If anything, it expands us. We are part of a universe that creates conditions for life, for awareness, for curiosity. We are not accidents or anomalies, but expressions of what the universe does when given enough time and the right ingredients. Carbon and oxygen and hydrogen forged in stars, scattered by supernovae, gathered into planets, assembled into living things that can think and feel and look back at the stars that made them. You are made of star stuff, as the astronomer Carl Sagan once said. The atoms in your body were created in the cores of ancient stars released into space when those stars died and eventually incorporated into the cloud that formed our sun and earth. You are literally part of the cosmos, not separate from it, not an observer standing outside looking in, but a participant, a piece of the universe that has become conscious enough to wonder about itself. And tonight, as you rest here, breathing slowly, you are connected to all of it. To the 2 trillion galaxies, to the countless stars, to the unknown planets and possible lives scattered across space. You share the same atoms, follow the same laws of physics, exist within the same vast unfolding story. The universe is not something distant and apart from you. It is what you are made of, what you are part of, what holds you even now as you drift towards sleep. Let that connection settle gently over you, not as a burden or a weight, but as a soft embrace. You belong here in this cosmos, on this planet, in this moment. You are exactly where you are supposed to be, doing exactly what you are meant to do, which right now is simply resting, breathing, allowing yourself to be held by the same forces that hold the galaxies. There is no grand task required of you, no need to solve the universe's mysteries or understand its full complexity. It is enough to simply be here, aware, present part of the ongoing conversation between matter and energy that has been happening since the beginning of time. And as you let that awareness fade, as sleep begins to find, you know that the universe will continue without urgency, patient and vast, waiting for the next moment of wonder. Breathe deeply now. Let your thoughts dissolve like stars fading into dawn. You are held, you are safe. You are part of something beautiful and ancient and ongoing. Rest now in that knowledge and let the universe carry you gently into sleep. We have traveled a long way together tonight, you and I. We began by looking up at the stars, wondering about that pale band of light stretching across the sky. We followed the story of human curiosity from ancient observers who had nothing but their eyes and their patience to modern telescopes floating in space, capturing images of galaxies billions of light years away. We learned that the universe is far larger than anyone once imagined, that what we thought was everything the Milky Way turned out to be, just one galaxy among countless others. We saw how Edwin Hubble discovered that Andromeda was not a nearby cloud, but a separate galaxy, and how that discovery opened the door to understanding that the universe was filled with such islands of stars, each one a world unto itself. We watched as astronomers counted galaxies, first estimating hundreds of billions, then revising that number to 2 trillion, and acknowledging that even that might not be enough. We looked at images from Hubble and James Webb, seeing galaxies scattered across every patch of sky, old galaxies and young ones, spirals and ellipses and irregular shapes, each one beautiful in its own way. And we thought about what it all means. 2 trillion galaxies each, containing hundreds of billions of stars, each star potentially surrounded by planets, each planet a possible home for life. The universe is not empty or lonely. It is abundant, overflowing with light and structure and possibility. And we are part of it, connected to every distant galaxy, by the atoms in our bodies, by the laws of physics that govern everything, by the simple fact that we are here conscious and aware, able to look up and wonder. But now the journey is complete for tonight. The story has been told gently and slowly, without hurry or pressure. And now it is time to rest, time to let go of the galaxies, to release the numbers, to allow the cosmos to fade into the background as sleep comes forward to meet you. The galaxies will still be there tomorrow. They are patient. They have been shining for billions of years, and they will continue to shine long after this night has passed. They do not need you to watch them, to count them, to understand them. They simply exist quiet and luminous, doing what galaxies do, turning slowly through space, creating stars evolving through time. And you here, in your bed, in your room, on this small planet orbiting a small star, in one of those 2 trillion galaxies, you can rest now. You have done enough. You have wondered enough. You have thought enough. Now is the time for letting go, for allowing your mind to grow soft and still, for permitting your body to sink deeper into the comfort of your bed. Feel the weight of your head on the pillow. Notice how your shoulders have dropped, how your arms lie heavy at your sides. Your legs are relaxed. Your feet are still. There is no tension anywhere, no holding, no effort. Just the gentle pull of gravity, the soft embrace of the mattress, the warmth of the blankets around you. Your breath is slow now, so slow. Each inhale calm and effortless, each exhale releasing whatever small thoughts remain. You do not need to control your breathing. It knows what to do. It has been breathing you since the moment you were born, and it will continue through the night, steady and reliable, asking nothing of you. Let your thoughts drift like clouds across a summer sky. If a thought appears, let it pass without holding onto it. If a worry surfaces, acknowledge it gently and then let it float away. There is nothing that needs your attention right now. Nothing that cannot wait until morning. This moment belongs to rest, to release, to the sweet descent into sleep. Imagine yourself floating in space, not cold or frightening, but warm and safe, held by the same forces that hold the galaxies. You are weightless, suspended in the gentlest darkness, surrounded by distant points of light that glow softly without demanding anything from you. They are simply there, keeping you company, watching over you as you drift. The universe is vast, yes, but tonight it feels close, intimate, like a blanket wrapped around you. All those galaxies, all those stars, all that light traveling across billions of years, it all exists in harmony, in balance, in a peace so profound it cannot be disturbed. And you are part of that peace, resting in it, held by it. There is nowhere you need to go, nothing you need to do, no questions that require answers, no problems that need solving. Just this moment, this breath, this gentle fading of awareness as sleep comes closer, wrapping itself around you like the softest fog. Your eyelids are heavy now, so heavy. If they are still open, they can close. If they are already closed, they can stay that way, resting, relaxed, comfortable. There is no effort in sleep. It comes naturally, like water flowing downhill, like leaves falling in autumn, like the universe expanding slow and inevitable and entirely without strain. Let the story of the galaxies fade now into a dream. Let the 2 trillion become 2,000, then 200, then 20, then 2, then one soft point of light that glows gently in the darkness of your mind. And then let even that fade until there is only the quiet, the stillness, the deep and peaceful dark where sleep lives. You are safe. You are held. The universe cradles you as it cradles everything with patient indifference and perfect balance. And in that cradle, you can rest, completely releasing the day, releasing the thoughts, releasing even the need to be awake. Sleep is coming now. You can feel it at the edges, soft and welcoming, ready to receive you. Do not resist it. Do not hold on to wakefulness. Let yourself fall gently, easily, like a feather drifting down through still air, landing softly on the surface of dreams. The galaxies are still out there shining in the night, but you do not need to watch them anymore. They will keep their vigil without you. And when you wake, they will still be there, patient and luminous, waiting to be wondered at again. But for now, sleep. Deep, restful, peaceful sleep. Let it take you completely. Let it carry you away from this place this time into the quiet country of dreams where nothing is required, nothing is expected, where you can simply be floating freely, resting deeply. Good night. Sleep well. May your dreams be filled with starlight, with the gentle glow of distant galaxies, with the peace that comes from knowing you are part of something vast and beautiful and endlessly patient. The universe holds you. Sleep holds you. And in that double embrace, you are completely, perfectly safe. Rest now. Just rest. The night is yours and sleep is yours, and all you need to do is let go and drift and fall softly into the deep, welcoming dark. Sleep well.